Hello everyone. This quick video will give a brief demonstration on how to use the Quick Guide to Statistical Test. Pictured here is the Quick Guide. You will notice one side is gray and one side is blue. This side, the gray side, will always refer to as tests that can be done with data that are parametric or interval level. Conversely, the blue side includes statistical tests that are conducted with non-parametric data or non-interval level data. Please note that when you have highly skewed interval data, it is suggested that you use the non-parametric test due to the fact that the data are not following the normal curve, which is an assumption of parametric data. Speaking of data, there are levels of data that need to be considered before one chooses a statistical test. The level of the data, or the level of measurement, as it is often called, refers to that of the dependent variable. What level of measurement or what level of data is the dependent variable of your particular study? There are actually two categories of data levels or measurement levels: interval or non-interval. Interval includes parametric data. These are data that are interval level or ratio data. These are numbers that can be added, subtracted, multiplied, or divided and still have a value. They are usable continuous data that can be used numerically. You can find a mean and standard deviation for interval level data. And since all ratio data is still interval, we just refer to it as interval. But note that ratio data refers to data with an absolute zero. And all ratio data is still interval, but not all interval data are ratio. Conversely, non-parametric data are levels that are nominal or categorical, such as naming something or putting it into a category, or data that are ranked. These are called ordinal level data. Ordinal level data are usually on a Likert scale, numbered from 1 to 5, and those numbers represent a placement on a rank or an ordered value, not so much as an absolute value, which could be added. So, for example, if you have a satisfaction scale from 1 to 4, 4 being the most satisfied, you can't say the patient had a satisfaction value of 1 in the first day of their hospital stay and 4 at the second, so they had a mean satisfaction rating of someplace in between that. Those numbers have to be analyzed differently when they're ranked. The exception is when ordinal or ranked data are converted to scores. The word scores should key you into the author has somehow taken the ordinal data and turned it into a number that they can then mean, and then it is therefore considered interval. So again, looking at the quick guide, on the one side of the quick guide, indicated by the pointer here, we have statistical tests that use interval level data, or variables, I should say, that are interval level data, also known as parametric data. These are parametric statistical tests. Conversely, on the blue side are non-interval data. So these are anything that is ordinal or ranked variables. These are always the dependent variables we're talking about, or highly skewed interval data. And notice the line in between, such that for every parametric test listed here, there is a corresponding non-parametric test. The only difference is the level of data. So we have a chi-square that is used to compare proportional differences, if those differences are interval level data, or if they are non-interval, that test is done pretty much the same, still called a chi-square. However, with the independent t-test, when you change the level of data, then you would use the Mann-Whitney U-test. So interval data used with two groups, one variable measured one time only, use the student t-test. If you have two groups, one variable measured one time only, you would use the Mann-Whitney U. So parametric, corresponding test for non-parametric data. In using the quick guide, use this tip sheet also included in your course to help you determine if a statistical test is correct or not in a given scenario. Try not to guess. Use the quick guide as a reference and also use this tip guide to make sure that you're staying methodical. So the first thing you want to do, given a scenario, is pick out the dependent variable. The dependent variable, remember, is also known as the outcome variable. That's the one that we need to know so that we can choose a statistical test. The dependent variable. Then next you ask yourself, what is the level of data of that dependent variable? That is it interval or non-interval? If it's interval, just think of the tests that are listed on the gray side of your table. If it is non-interval, or other words, nominal or ordinal, think of a test on the blue side for non-parametric test. Then next, ask yourself exactly what is this question asking? What kind of study is going on here? Am I simply describing something? Am I comparing something? Or am I correlating? Once you decide that, then you can go down the test and pick out the test that meets the criteria, and that would be your answer. Again, looking at the quick guide, the top row, indicated by the pointer here, the top row is for describing. So statistical tests that describe only are called, easily enough, descriptive statistics. They don't compare, they don't correlate, they only describe. They give you means, percentages, medians, modes, frequencies, things like that. They're not comparing, they're just describing the data. You can do that in a non-parametric and parametric fashion. The chi-square is a comparative statistic. The key word in any exam that I give is proportional. And again, the chi-square can be with parametric data, can be used with parametric data and non-parametric data. The independent t-test, the paired t-test, the ANOVA, and the repeated ANOVA, these four tests are comparative statistics. And if you are comparing two groups on one variable and only measuring them one time, for example, after an intervention, you do a measurement, the student independent t-test is appropriate. If you, for example, have one group, and again, one variable, but you are measuring this two times, perhaps pre and post an intervention, then you could use the paired or dependent t-test. The ANOVA test, one way, two way, or whatever type of ANOVA you have, generally is used when a criteria for the independent test is broken. Ergo, the blue dotted arrow. So perhaps you have three groups being compared on one variable. The important thing is with the ANOVA, it is only measured one time. Now you could have two groups, or you could have 5 groups, 10 variables. As long as they're only measured one time and the groups are independent, separate groups, then you could use the ANOVA. The repeated ANOVA is when you do not have the criteria for a paired t-test or the dependent t-test. So perhaps you have two groups, one variable measured 2 times. That doesn't fit that criteria, so you would go to the repeated ANOVA. Repeated ANOVA can be two groups, two variables measured 4 times. It could be one group, two variables measured 2 times. It could be several things. What it is not is one group, one variable measured 2 times. Lastly on the table are the statistics used for correlation, looking for association between two variables. The Pearson product moment is the correlation exam, or the correlation test rather, for parametric data. Find your dependent variable or variables, plural, and ask yourself the same question as you did before. What is a dependent variable? What is the level of that dependent variable? And if you are correlating, these are the statistics you would use, this bottom row. Pearson product moment, or Pearson's R as it's sometimes called, for parametric statistics or for interval level data. Spearman rank correlation for non-interval data. The phi coefficient is a special case, and it is used for correlating two dichotomous variables. That dichotomous, I mean an either or. You have a yes-no on one variable and a yes-no on the other. Those are dichotomous, only two possibilities. Again, this information is covered elsewhere in the videos that you are required to view for this course. This video was just intended as a quick video on how to use the Quick Guide to Statistical Test.